I now want to look at solving inequalities involving absolute value. In absolute value inequalities have two cases. So let's start with the less than case. And let's start with a really simple example, like the absolute value of x is less than 3. Well, while there are infinitely many possible answers to this, let's think of some things that have an absolute value that is less than 3. The absolute value of 2 is less than 3. The absolute value of 1 is 1. That's smaller than 3. The absolute value of 0 is less than 3. -1, -2. However, we stop because if I were to consider -3, the absolute value of -3 is 3, which is not smaller than 3. So we can see we have a cutoff point. And in general, this works if x is between -3 and 3. In other words, the interval -3 to 3. And this is how it's going to work in general. If the absolute value of u is less than c, then we set up an inequality. -c is less than u is less than c. And there's nothing unique about the less than. It could be less than or equal to. There's nothing stopping the or equal to case here. And it works the same way. So let's do a few examples of this before we look at the second case. Let's start with 2x plus 1 is less than or equal to 7. So the less than or equal to tells me I need to set up my inequality. -7, less than or equal to 2x plus 1, less than or equal to 7. We then subtract 1 from all three sides, since this is a compound inequality. Get -8 is less than or equal to 2x is less than or equal to 6. Divide all three sides by 2, and we get -4 is less than or equal to x, which is less than or equal to 3. So my interval is between -4 and 3, in brackets since we are including these values. Now let's do the absolute value of 3x minus 5 is less than 11. So once again, we have a less than case here. So that means we need -11 is less than 3x minus 5, which is less than 11. We're going to add 5 to all three sides. -11 plus 5 is -7. -11 plus 5, or 11 plus 5 is 16. We then divide all three sides by 3 to get -7 over 3 is less than x is less than 16 over 3. So this time my interval goes between -7/3 and 16/3, and we use parentheses since we are not including the endpoints. Let's now consider the other case, the greater than case. Let's suppose we know the absolute value of x is greater than 3. Once again, this has infinitely many solutions, but we can think of some things that satisfy it. The absolute value of 4 is greater than 3. Same thing with 5, 6, 7, and we can consider this pattern indefinitely. And then the absolute value of -4 is also greater than 3. The absolute value of -5 is 5, which is greater than 3. And so we also go down in the negative direction. So in this case, it would actually be everything from -infinity up to -3. Or we use this symbol U, this union symbol for or. It's larger than 3. So we actually have two pieces here. And this is going to consider in general. If the absolute value of u is greater than c, then we set up two equations. U is greater than c. That corresponds to these values, x being bigger than 3. Or u is less than -c. Since we're looking at negatives, we need to move that to a less than, and now we're going to be looking at these numbers here. And once again, we could make this greater than or equal to. Then we would have u greater than or equal to c, or u less than or equal to -c. So let's look at some examples. Let's suppose we have the absolute value of 2x minus 4 is greater than 12. Since this is a greater than symbol, we need two equations. 2x minus 4 is greater than 12, or we could be considering numbers like negative 13, negative 14, negative 15, etc. So we need 2x minus 4 to be less than negative 12, since negative numbers run backwards. For the inequality on the left, we add 4. That gives me 2x is greater than 16. Divide by 2, so x is greater than 8. So this means 8 or bigger, so 8 to infinity. For the inequality on the right, we add 4. That gives me 2x is less than negative 8. Divide by 2 to get x is less than negative 4, so it could also be smaller than negative 4, so negative infinity to negative 4. And we would union these two intervals. The U, union, means or. Next, let's look at the absolute value of 3x plus 2 is greater than or equal to 14. So once again, we have the greater than symbol. So that tells me I have two equations. 3x plus 2 is greater than or equal to 14, or 3x plus 2 is less than or equal to negative 14. On the left, I can subtract 2 and get 3x is equal to 12, or 3x is greater than or equal to 12. Divide by 3 to get x is greater than or equal to 4. So it could be equal to 4, or it could be bigger. We use a square bracket on 4 since we're including 4. On the right, I can subtract 2, get 3x is less than or equal to negative 16. Divide by 3 to get x is less than or equal to negative 16 over 3. So it could be negative 16 over 3, or it could be smaller than that. So we join these two intervals here. There are a couple of special cases we may come across. So let's consider the idea of negatives here. And this is also going to depend on the inequality. The absolute value of 3x minus 4 is less than negative 2. Well, this would have no possible solution. Since it doesn't matter what we would stick in for x, an absolute value has to be positive. It cannot be smaller than negative 2. Here, on the other hand, we want the absolute value of 3x minus 4 to be greater than negative 2. So this would actually work for all numbers. It doesn't matter what you stick in for x, the absolute value will be positive, which will be greater than negative 2. So we do have two strange cases here. And absolute value inequalities can be really tricky because you really do have to pay attention to which direction the inequality is facing. So be very careful and just kind of make sure you watch what you're doing and you should be fine.